I didn't realize I was thinking like an architect until I made a decision that has nothing to do with code. Absolutely nothing to do with code. That was when I realized that I think I'm beginning to think like an architect. And at this time, it was not about any framework, that decision I was making, that thinking. I wasn't thinking about any framework. I wasn't thinking about any new library, any NuGet package, any Maven library or whatsoever. No, I was not thinking about any complex implementation. Not at all. At that point in time, I was focusing on a very simple question. Just one question. And I need to answer that question. I need to give an answer to that question. So that brought me thinking about that question. Wondering, what should be the solution to this very simple question? Because that's the kind of question that engineers that wants to become architect should be thinking about. Very simple question, like I said, but very uncomfortable question. And what is that question? The question is simple. What should the system do when things go wrong? Because for every system, at some point or the other, things will go wrong. Take a look at human beings. We are all systems of systems. You know, we have the heart, you have every part of the body. Things are going to go wrong. You fall sick. Some get cancer. Some have one problem or the other. So when the system goes wrong, what should when things go wrong, what should the system do? That is why God created all of these, things within us that fight diseases. That question completely changed how I think about systems. Because before then, you're thinking about systems, you're building systems, you're just, doing the work, finishing your PRs and the likes. But now you're thinking about the entire system. Not just, what should I optimize? Not just this or that. You're thinking about, in the event of eventuality, how should the system react? Most engineers, they don't operate at that level. They operate at the level of what should they focus on. Things like fixing the problem. Things like, improving logic. Things like optimizing performance. Those are the things they focus on. But for me, at that time, I was focusing beyond that. And I'm not saying there's anything wrong with that. No. That is not wrong. You got to fix problem. You got to focus on optimization. You got to focus on improving, definitely. You got to focus on using different kind of technology, either direct SQL, either you're going to use some DAPA, framework and the likes that helps you to do pure SQL. Or sometimes you're going to optimize your EF core framework. You're going to optimize your Hibernate and the like. Most of us grow doing this. In fact, myself. But at this point in time, the situation was different. I was in a total different situation. This wasn't about fixing the problem after it has happened. No. This is not about post-mortem. No. This was me thinking about, what should I do now in the moment? It's about detecting. It's about deciding. It's about understanding and knowing ahead how the system should behave. How the system should react. How the system should heal when problems occur. Because problems will occur. There will be problems happening. It could be one, it could be two, it could be many. What should system do when the problems occur? And that was where the shift happened for me. Not in my skill set, but in my thinking, how I think about systems. This happened while working on a payment gateway. And payment gateway are not like typical systems. They are systems that are a bit different, And because when it comes to payment gateway, it's talking about movement of transactions from one place to the other. It could be from one region of the world to another region of the world, but data is moving, and it's moving very fast. It's moving very quickly, and it's not just data. We're talking about money here. We're talking about moving money across systems. Your systems to another system, from that system to another system. Take for example, when you transfer money from your phone, from your banking app to another country. It goes through your banking app to the bank infrastructure, maybe the APIs in the bank. It doesn't stop there. It goes as far as getting into the backend system, the banking platform, and then it goes through another channel, through the network, to the gateway, from the gateway to another provider who now connects back to the other bank that is going to the other country. And sometimes it could be even going through switch. Sometimes we're going through some other transfer mechanism, Stripe and the likes. And when it gets to your own bank, and after it gets to your bank, it gets credited to your account, and you get an alert on your phone, and your mobile app shows you what has happened. Imagine such a long flow of system. And when you are in such a long flow of system, then everything changes. Because now at that moment, money is involved. And there are multiple failure points along the way. So you're not just going to be thinking about, oh, money is just going to move. Any of those systems can break down. Not just that. You don't control fully all the systems that is a part of that transaction. You depend on external systems here and there. Even the one that is going to call your own system, first system calls the other system. And you rely on responses from those systems to determine your own state. And you cannot guarantee how those systems are going to react. You cannot guarantee even their responses. Sometimes you're going to send requests, they're going to fail on you, you're going to time out on you. And that environment is an environment that is full of uncertainty. In fact, it's not just full of uncertainty. You must assume that things will go wrong in that environment. You must consistently assume that things will go wrong, which means you cannot assume everything will go all right. And when they do go wrong, your system must behave correctly. Otherwise, you lose customer. You lose customers' faith in your system. So your system must behave correctly, even when those other systems, third-party systems, go wrong. You must be predictable. Because in payments, failure is not just technical. Failure is not just about, oh, okay, yeah, if it failed, we can try it or something like that. It goes beyond technical. Failure in payment is trust. Broken. Failure in payment is people saying, you cannot rely on this system. I cannot, because nobody wants to play with their money. Because if money disappears, if transactions are duplicated, because it's going to happen if you don't plan for them. If users don't understand what happened to their transaction, to their money, the transfer, it happened to me several times. When I was in Nigeria, you do transfer and you're wondering what has happened. It debits you the first time, debits the second time, debits the third time, and they didn't get anything on the other hand. When those happened, it's not just a bug. Yeah, you don't just have a bug. You have a bigger problem than a bug. A credibility problem. Trust deficit problem on your platform. And I'm sure you don't want that. Because of this, every decision matters. Every decision matters. Particularly decisions that you're going to make around failure. So, here was the situation. Here was the scenario that I was thinking about. A user initiates a transaction. Let's look at that scenario. A user sits on his mobile app, probably, or maybe you're using SMS, using mobile banking, and initiates it. Even on your web portal, I mean, the banks have web portal, money houses have web portal, even investment portals could also be one of it. So initiate a transaction. That request is sent to the bank. I mean, you got to send it to the bank. You are not a money house. When you're talking about payment platforms, you send the request to the bank. And not just sending the request to the bank. Everything looks normal. End to end, closed. So you can go and relax. But suddenly something goes wrong. Suddenly, things that looks normal is not normal any longer. Maybe the bank's times out. That could be the case. The bank's channel could time out. The channel might even be available, but transactions are timing out. Maybe the response is delayed. It's not just timing out. It's actually going to be successful, but much more slower. And that is going to impact your system. Even maybe the transaction is processed, but it's processed at the bank, but you didn't get any confirmation that it's processed. So you're wondering what has happened to that transaction. You see, all of these scenarios and many more are what can happen when you send money from the phone. When the user initiated that transaction, to either to pay for goods or services, or to transfer money from one bank to the other, trying to transfer money to his friend or across the nation called IMT, International Money Transfer Operations. That is what happened. Now, when things didn't go well, pause for a moment. Because if you don't pause, this is where most engineers react instinctively. What should I quickly do? No. The instinct is not for you to just, how do we fix this? No. So that's what most engineers do. How do we fix this problem? What should I do next? No. You don't react instinctively in such situation, because that would be the wrong question for you to ask. How do we fix this? No. The question to ask is, this has happened. What should the system do next? When you begin to think in that way, that okay, this has happened now, what should the system do next? Probably you didn't plan for it. When you're thinking about what the system should do next, a couple of options will come to you. And that question will change the way you think. That is just a fact. That question will change the way you think. It will change everything for you. Because now, you are no more reacting. Rather, you are making decisions, you are deciding. You are no more reacting, you are deciding. And that decision will define how system behaves in real world conditions. When you are testing with the banks in their environment, it will always succeed. Why? Because there is no transaction going through it. There is no pressure. There is no, there is no load on the server. But in real world conditions, it differs. So you must anticipate it will never be an ideal condition in the real world. Have you seen why? You just ChatGPT, Gemini AI, or whatever AI, and sometimes they're not even available. You send a message and it's loading and loading and loading and never come back. Sometimes you power down, sometimes you close the applications, you restart it and nothing happens. Those are real conditions. When you do such payment system like the payment system I was talking about, that you must plan for. They are unpredictable conditions. They are failure conditions, and you must plan for them. At that point, we had multiple options that we can look at and try to do. Multiple options. And this is where architecture becomes real. Because architecture is about options. You don't just sit down and figure out this is what I'm going to do and do it. No. You must have options. You must be able to choose. There must be consensus. You don't just pick a solution and slash it in and you start implementing it. No, that's not architecture. Options, very important. Alternatives you have considered, because each option carries their own risk that you must be aware of. Because now, you're not just choosing code. No, you are choosing the system behavior. You are choosing what? The system behavior. Let's walk through some of them that we try then. Some of the options that we consider. Number one, retry automatically. You didn't get a response back, there was a delay, you retry automatically. On the surface, it makes sense, does it not? It does. It makes sense on the surface. It looks like it's going to work. If something fails, just try again. Simple. But now, think deeper. What if the first transaction actually went through? But it's just that the response was delayed and you have tried again. Can you guarantee that that will not be a double transaction? Because when you retry, it may create duplicate. And in a payment system, a duplicate is not a small issue. Someone being charged twice, or someone being credited twice, that is a big issue. So, simple retry will have created bigger problem. Because that's what you would do. You try to connect to a network, it didn't connect, you try again. So that mentality, you break it into payment, you create problems. You create bigger problems that you might not be able to deal with. Because that small duplicate is big in problem. Because you never can guarantee what the system will do with your second transaction. You can say, okay, yeah, then I can go for option 2. I can fail immediately. Yeah, that is also, very good option too. Fail immediately. Because I cannot guarantee what the system will do if I try. Just fail. Oh, it's safer, yeah. If anything looks uncertain, just fail. Tell the customer, it didn't succeed. It didn't succeed. Even though it looks simple, fail it, return an error. What about the user? From their perspective, they've attempted to try and pay for something. They've attempted to transfer money somewhere as a user. And it didn't work. What does that look like? Unreliable systems. What does that mean to business? You begin to lose customers. You need to think about all this. Even if the bank actually processed the transaction, but because you failed it, you have introduced confusion. Now they see their bank debited. They see your system say it's not successful. What they paid for is not yet paid for, but it's debited on their account. What should your system do? There are so many concepts about, for example, card payment on how you handle such. Where you first do authorization, you first do something like pre-auth, where you put the money there, you're not debiting yet, you just register the transaction, and then you say it's successful, and then later you go and debit the money once actually it's successful. There are many things you could do, but from the user's perspective, you have introduced confusion. Now there is a third option. Wait for confirmation and don't do anything. So that makes sense. This sounds more balanced. Just wait for confirmation. Until they confirm, you don't do anything. Wait until you are sure before you take the next steps. It looks plausible, right? It looks okay. But the question will now be, how long do you wait? Do you keep rolling on the screen, doing loading and loading and loading? Or do you show some messages and tell them to check back? What if the confirmation never comes? So you have to make decision in all of this. Because if you don't see anything, that's the scenario, your system is stuck, not failed. If it's failed, you have deterministic outcome. If it is retiring and it's finally failed, deterministic outcome. But now you are stuck. They don't even know what is happening. It's not failing, it's not successful. Then what is it? What happened to the transaction? Just uncertain. And in the payment system, uncertainty is dangerous. Because your systems didn't handle ambiguity the way it should handle it. It didn't handle it well. And that's when it became clear to me. In all of these scenarios, there is no perfect answer. Not at all. No perfect answer in all of those scenarios I've just talked about. What do we have? Trade-offs. And that is the number one principle of architecture. What are your trade-offs? There is no perfect solution anywhere. What you have is perfect trade-offs. Your trade-offs. Anything else like that doesn't exist. Now, up until that moment, my thinking was still rooted in execution, execution, execution. How do we handle failure? How do we, if the system fail, what should I do? That is all I think about. Execution, execution, execution. But when I begin to think about this situation, it shifted my perspective. I began to think differently. I began to ask myself deeper questions. I began to take notes. I had a book. I began to write out different ideas. This can happen, this can happen, this can happen. I began to go to the whiteboard, on my own, not with anybody, just drawing and drawing and drawing and putting links here, putting links there. This one should link to this, one should link to this. What behavior do we want to guarantee? No matter what happens within this system. That was the question I was trying to sort out for. I was trying to solve. What behavior in this system do I want to guarantee? Do we want us the system to guarantee? That's the shift. That is the bigger shift that happened to me. Because now, you're not just reacting to problems. At that point in time, you are not reacting to problems. You are defining how your system should behave. How the system should behave. Because you have gone beyond, trying to solve problems. You are saying, there will be problems. You are no more avoiding problems. Let them come. Even when they come, this is what the system should do. Guaranteed trade-offs that the system should overlook and guaranteed things that the system should cater for. You are making decisions. You are deciding what consistency means for your system. When your system is consistent, what does it mean? What failure means for your systems? And what trust means in your system that the customers, the users, can take as the currency of your systems. And once those are defined, the consistency, the failure, and the trust, everything else follows. The developer knows what to do. Everything else will follow. Once you can define consistency, the failure, and trust, what it really means in your system, everything follows. The code follows. Because the code is now being written to sort for those things you have defined. The implementation follows that same pattern. The logic they're going to put in the code follows that same pattern. Everything else will follow that design that you have put together, that you have aligned your stakeholders on. They all become secondary. Because the fundamental thing has been sorted. That is it. Because they are now executing decisions, not trying to solve problems. They are executing decisions that they can totally take care of. They are not creating decisions with their code. Oh, if A equals to B. No, it's not their place. They execute your decisions and not creating one. And that's architecture. That was the moment it clicked and really clicked for me. Architecture is not about building system. It's not just about that. It's not just about saying, let's build system. Architecture is about making decisions. It's about making decisions under constraints, because there will always be constraints. Constraints of the system interconnections, the external dependencies you are going to be connecting to, integrating with, the interface specifications they have defined that you need to catch up with, you need to implement, your own system internals. But not only that, constraints on the knowledge of the developers, constraints on languages to use. That define behavior. Those constraints, they define the behavior. Not when things go right, because that's not what is important. when it comes to architecture. That is the happy part. It's the simple way to deal with. But when things go wrong, how should your system behave? That is architecture. When things go wrong. Because when things go wrong, that's when your systems is really tested. That's when systems are tested. When things go wrong. When things keeps going right, I mean, nothing is tested. You're just doing your system is just running as usual. But when things go wrong and your system recovers, and your system behaves the way you are planning to behave, that's what architecture is meant to do. Because your assumptions are exposed. If you don't make the right assumptions, when things go wrong, your system will blow out. Your system will misbehave into the face of the users. And you don't want that. You don't want to have weak design, because they'll become visible when things go wrong. And if those decisions were not made carefully during the design phase, no matter what you do, no matter how you patch your system, no matter the amount of resources you throw at that system, the system will reveal it to the user. See me, this is what I'm made of. It's going to happen. I'm not going to just do it once. It will always happen every time. I've seen it over the years. It's a continuum. System will always reveal weak design, weak assumptions, weak boundaries. If you're not properly designed, they will all get exposed. So as an architect, or as a will-be architect, as an upcoming architect, you've got to focus on your trade-offs. You've got to focus on answering that question. What the system will do when things go wrong. Wrong assumptions, they will get exposed if you don't plan it. Yes, they will get exposed. Unclear behavior, you have not defined a clear behavior for the system, it will get exposed too. It will get exposed. And no amount of coding, like I said, can fix that. Because that problem is not an implementation problem. Not at all. It's not an implementation problem. It's a decision problem. If you make the right decision, yeah, the system will work the way you want it to work. So after that moment, everything changed for me. Yeah, everything. Everything changed for me, really. The way I see systems changed totally. I stopped seeing system as code. Oh, I just have to write code programs. No, I stopped seeing system as programs. Because systems are not just programs. No. That's where we miss it. We think systems are just programs. No. And I started seeing them as behaviors. As what? Behaviors. Because systems are also behaviors. So I stopped asking questions like, how do we build this? No, that's not what I'm thinking about. First, my question, the one I start with, is what should the system guarantee? So when I'm going to build a new system tomorrow, first question I ask myself is, this new system, what should it guarantee? I know what that means. That's fit into the requirements. No matter what happens, what should the system guarantee? How should the system react? How should it behave? That fits into the requirement. Early, that's what we call, non-functional requirements that users may not even know that they need. But you as a developer, as an architect, must be able to come up with such requirements. What should the system guarantee, no matter what? All of the abilities, all of the cyber security, this and that, many things, maintainability, and all of those, all of the abilities, really, all of the abilities. That's how you begin to think about them. And you know what? That's when I realized something very important in my career. That's when I realized something very, very important, which is, this is the first time I really think like an architect. I didn't write a single line of code. I didn't have to be one of the engineers that is trying to do the coding. But I made a decision. And that decision shaped the entire system behavior. How the system behaved. That's when I knew that no more was I working like an engineer or thinking like an engineer. I've scaled. I'm now thinking like an architect. Yeah. That's when it dawned on me that I'm no more just an engineer. I'm now a real architect. In the next video, I'll show you something more uncomfortable. Even more uncomfortable than what I just shared now. Why even correct architectural decisions still fail in real system. You've sat down, you've done everything I'm talking about, and you go to production and you still fail. Come on, I planned this, we cater for this, how come it failed? I'll show you my next video. It has nothing to do with technology, most times. If you are designing this system, this payment system I've explained in this my video, what will have been your choice? Retry, fail fast, or wait? Retry, fail fast, or wait? What will have been your decision? Or maybe you have some other options you want to share. Put it in the comments. If you want to move beyond coding into real system thinking, into real system, architecture, subscribe to this channel. Because this is where architecture actually begins.